So alternative to practical topic 2, topic portion extension question number 2. So in the question, a student is investigating the extension of a spring, measuring how much the length increases. Figure 5.1 shows a spring with and without a load. So we have to take the distance that shows the extension of a spring when load is added. So which distance, A, B, C, or D? Which one is representing the extension correctly? You can use the chat or you can also use the screen annotation to mark the answer. Look, the correct answer for this one, extension means increase in length. So A is not the right answer. Why A is not the right answer? Because A is not the increase in, if you want to calculate extension, extension means how much length has increased. And we have to take the identical points for why it cannot be B, even B is wrong. Why it's wrong? Because we are measuring from a start of the hook till the end of the hook. Like we should take the same point when we are measuring the change in the length. So C is the right answer. Why C is the right answer? Because from we are taking like identical point. When we measure the extension, like we measure the extension means how much length has increased. So if the first distance we measure from end of the hook, the second distance should also be from the end of the hook. Why B is not correct? Because in B, one point is starting, another point is end. So we did not take the identical point. When we calculate how much length has increased, so we have to take identical point. Either we can take both ends or we can take for starting of points also. But we should take the same identical point to work out the extension. So C is the right answer. Is it clear?
Yes, sir, clear.
So extension means how much the length increases and you have to take from the same position. Then the graph shows the results of student. State whether the graph shows that the load and extension are directly proportional. When two quantities are directly proportional from the graph, first thing, it must be a straight line. That is the first thing. And the second thing, it should pass through origin or starting from origin. So it must be passing through the origin. So when we check, they said that they are directly proportional. So first thing we check, it is a straight line. The second thing, it should pass through origin. So both are, so we'll say statement, we'll say yes. And the reason is that we'll mention because it is a straight line. So it is a straight line passing through origin. The line is passing through origin because this point is called origin. So it is straight line which is passing through origin. If it was a straight line, but for example, if it is above the x-axis, above the y-axis, or it is starting from x-axis, then we will not say it is a directly proportional. But you can clearly see that it is a straight line and which is starting from origin 0 and 0. Is it clear?
Yes, sir, clear. So, Mr., this is a graph to Hooke's law, right?
Yeah. The straight line passing through origin shows that it is directly proportional. Then the student determines the gradient and he got the gradient to be 0.17444729. And they said the value of the G is numerically equal to K, the spring constant. So whenever you're writing the value, you should always use three significant figure. So they said gradient is equals to k. So what is the value of gradient? That will be same as k. But we'll not write full. We'll just write the three significant figures. So we'll write 0.174. And then unit, how to work out the unit? You have to check the graph because unit of k is force divided by extension. The value of the k, when we calculate, it is force divided by extension. So force is in
So
Newton
it's
and
Newton
extension is
per
in
millimeter.
millimeter. So we'll say that it is 0.174 Newton per millimeter. So 0.174 Newton per millimeter. How we work out the unit? Because we know K is the force divided by extension. So force is in Newton and extension in millimeter. In question 3, the class is investigating the stretching of a spring. Figure 1.1 shows the apparatus. So the length of the spring is there. In the question on figure 1.1, measure the length L0 and record L0 or L0 in the table when load is 0. So what we have to do, we just have to use a ruler or the scale and measure this length.
It's equal 1.2.
1.2 or 1.1, 1.2, 1. But see, it is given in millimeters. So if it is 1.2 or 1.1, so you have to multiply by 10. So it will be 11 for you. And if you are getting 1.2, then you will say it is 12. As I mentioned, because our paper size is different from the actual paper, that's why we don't get the actual marking scheme answer for this one is 15. But we'll not get 15. Why we'll not get 15? Because the paper size is not the same scale. That's why. So you will write accordingly, but not in centimeter. You have to convert into millimeter. Then explain why L naught is not measured to point X in the spring. Like why we did not measure till point X. We just measure the length of the coil. Why we ignore X?
Because it doesn't extend. It didn't extend.
Yeah, because what will happen? Won't change the length when even extension is there. It will not change its length. That it will remain fixed. Only thing what happened when we add a load here. For example, if we were having a spring and we add a load to a spring, so this part will remain same size when the load is added. Only thing what happened, the length of the coil will change. So the reason why we ignore this to did not measure the value of X because X does not deform or X does not change the length. So the value of the X does not change even we add any load. Then we have different loads are there 1, 2, 3, and we have the extension. Describe one precaution in order to make the result reliable. Whenever we are measuring the length of a spring, so we should always look perpendicular or avoid parallax error, or we should wait for a spring to stop vibrating because if a spring is vibrating and you try to measure the length, it won't be accurate. So usually what we do, we allow the spring to settle down and then we measure the length. So what precaution we can take? You can mention avoid parallax error, look perpendicular. And the second thing, what you can do, you can wait for the spring to settle down or stop vibrating. Before taking the measurement. So these are the two things we should do to get a reliable results. In case any point you want me to repeat, I will explain that again. Then we have to plot a graph and the values. What are the values we have? We have 0 and it was 15. It was 11 or 12 for you, but I'm using the answer from marking scheme. So 15, When it is 1, it is 17. When it is 2, it is 20. 3 is 21. 4 is 23. And 5 is 25. This one is a force. And here is a length. Now the next part we have to, for physics, you have to select a scale as well, because so see, we have to plot on x-axis should be length, on an y-axis is a load. So for x-axis, if we need a length, so we can select like our scale. It's they did not mention you should start from origin in the question, as they did not mention you should start from origin. So what you can do, you can start with any number other than 15. You can start other than 0. You can start, like example, the first value, say we took, because we don't have any number there. So example I took as 10. Then after 10 boxes, it will be like, because what we want to extend the scale till 25. Maximum value for the length which we are having, that is 25, and the minimum value is 15. So if they did not mention that you should start the graph from origin, you can start with any number. Say we are starting with 10, and then after 10 boxes, I'll just zoom in. So we have after 10 boxes, or even if I start with 15, no, you cannot choose the y. If they mention in the question that you should take on x-axis, you should, in the question they mention length is on y-axis and load on x-axis. So I have to take load. We cannot change. I have to take, yeah, if it is not in the question, you can. But in this question, they mentioned the length should be on y-axis and load on x-axis. So I should have a load on x-axis. I was making a length on x-axis, but it should be load. And load max, like 0 is there. Then after 10 boxes, example, we have 1. After another 10 boxes, 2. This was 2. Then we'll have 3 after another 10 boxes. But this scale, like if I draw in this manner, it appear that the scale will not cover, like we should cover about 70% of the graph paper. So we can even extend it. Um, so this is 4. This one appear to be 5. And I don't have the value after that, but I'm just checking if I take 20 boxes equals to 1. So this will be 1, 2. It won't fit. So even I have to choose this. Yeah, so it won't fit. So 6, 7, 8. And label the axis. 1 mark is for labeling the axis correctly. So we are making a load and the unit of the load is Newton. And on y-axis, we have from 15 to 25. So you can select, like example, we started with 15 example, or instead of starting with 15, say start with 10. Then after 5 boxes or 10 boxes, 15. How we know which one is independent and which one is dependent? Usually on x-axis you have independent and y-axis you have a dependent quantity. Like if you add a load, the length will change. So load is what you are changing and length is affected by the load. So length is the dependent one and load is independent one. Usually the rule of a graph, plotting a graph, x-axis is the independent and y-axis is the dependent one. But in this one, you don't have to select the dependent and independent variables because they already mentioned that length should be on y-axis and load should be on x-axis. So you just have to understand, like if I change load, length will change. So it means length depends on the load. It means length is depending on the load. So length is a dependent quantity. So I have to label the axis 1, 2, 3, 4, 5. The box size is so small, that's why I miscount. So first I'll mark after every 10 boxes, I'm marking the points and then I will label the axis. So if I have 10, 15, 20, like 10 is there, then 12, or I start with 14, reducing. So if I start with 14, then 16, 18, 20, 22, 24, 26. So it will be about like more than, so this will be example 16 is there, then 18, then I have 20, 22, 24. About more than 70% of the access I use, so that is appropriate. And here I plot length and the unit is millimeter, so I'll write millimeter. So on x-axis we have length, load, on y-axis we have length. Then we have to plot the results. I will roughly sketch this because the points are like the boxes are very small. So first we have 0 and 15. So 0 and 15 will be somewhat here. Then we have 1 and 17. So 1 and 17. Then we have 2 and 20, 2 and 20. Then we have 3 and 21, 3 and 21. Then we have 4 and 23. So 4 and 23. Then we have 5 and 25. So 5 and 25. So what we'll do, we'll draw a line of best fit joining these points. The best fit straight line, the number of the points above and below, we should have an equal number. And it's not necessary you join the first and the last point. Like if I draw like this, it appears that all the points are like on only one point is above. So this is not a best fit straight line. A best fit straight line should have equal number of the points above and below. So this is approximately, like one point is here and one point is down and one is closer. So it like balances the other points. Is it clear? This one?
Yes, sir, clear.
The next one, they're saying, the next part, they're saying that this is a graph for load and length. If the graph is there between the load and the length, it will never start, because when there is no load, there will be some length. If the graph was there between the load and extension, then it will start from origin. So the next part, the student suggests that the length of a spring is directly proportional to load. So as you can see, when we plot the graph, it was not starting from, it was a straight line, but not passing through origin. So whether the readings support the suggestion?
No, it's not supporting.
So we will say no. And reason is that because the straight line is not starting from origin. Origin does not mean, like, origin means 0 comma 0. Like example, if I'll give another example. So the straight line was not starting from origin, that's why. But for example, one student took the graph and plotted the graph for load and extension, and he took the values, like he started the axis for the length from 15. So it was 15, 16, 17, and so on. And this was 0, 1, 2, 3, 4. And when he plot the result, and his result was like this. Can we say they are directly proportional? Yes or no?
Yes, because it's a straight line passing through the origin.
We'll say no. But why we will say no? Because origin does not mean this point. Origin means 0 comma 0. So because the first point, this is 15 and 0, so it's not a origin. Origin means, like, if we have 0 comma 0, like a point is there on the line which is 0 comma 0, then we will say yes, it is directly proportional and starting from origin. So this is a, like, student got confused. They think like it's starting from the intersection of the two axes, it should be directly proportional. It depends on, if you start your axis from 0 comma 0 and it is passing, yes, we will say it is directly proportional. But if you did not start, like one of the axes you start with 0, another one with any number, then you will say no, it is not directly proportional. Is it clear?
Yes, sir, clear.
Then use the result to predict the load that would give the length twice of L naught. So example, as you took L naught was 11 millimeter or 12 millimeter, we want that load for which the length is twice of L naught. Like L is equals to double of L naught, means 2 into 11, which is 22. So we want to find the load when the length is 22 millimeter. So you have to show this on your graph. So when 22 is there, like this was our graph. And for example, your L, because it vary, your L naught might be, 11, as some mentioned, your L naught might be 12. So if those who got 11, they will find the load when the length is 22. But those who got 12, they will find the load when the length is 24. So example, if my original length was 11 millimeter, you will always select the line of best fit. You have to check the points. If the points appear to be, you have to draw a line of a best fit. So what we'll do, we'll draw a line from our graph when the load, when the length is 22, and then with respect to that, we'll find a load. So each box is 3.1, 2, 3, 4, 5. So we'll say that the load is equals to 3.5. How you will know that whether it should be a best fit straight line? In physics, most of the quantities, they should have a best fit straight line. Chemistry, you draw line, curves. but physics straight line graphs are there, so a straight line graph should always be best fit. So the load is equals to 3.5 Newton. Is it clear, this one?
Yes, sir. Clear.
Moving on to question 4. A student is finding the spring constant of a spring by two methods. Figure 1.2 shows how the apparatus use the method 1 on the figure. Measure the length of unstretched spring. What is the length of this spring, which is unstretched? So you just have to place your ruler or the scale and then measure the length of this unstretched spring.
So, Mr. 1.7 centimeter, so it's 70 millimeter.
So 1.7 centimeter or 7. So don't forget, like, check the units what are given. If the units are not given, you can write in centimeter. So if you are getting 1.7 centimeter, you have to convert into millimeter. So it will be 17 millimeter. And as I mentioned, the marking scheme answer will be different from your answer. Then the student attached the spring to clamp as shown figure 1.2 and he hangs 300 gram. So student add 300 gram. He measured the length, which is 53 millimeter. Then calculate the extension. So how to calculate extension? For paper 6, you don't have to learn any formula. Extension is L minus L naught. So this is L, which is 53. L naught was 17. According to your value, will work out. So example, it is 53 minus 17. So that is equals to 36 millimeter. And then calculate the value of a spring constant, which is K is equals to F over E. So F is 3 and E was 36. So 3 divided by 36, what's the answer? Which is 0.08. So you'll say 0.08 and Newton per millimeter. Write your answer in three significant figures. But if it is like 0.08, you cannot add any other. Then question 5, the student investigating how a material of a spring can affect its behavior when it is stretched. The following apparatus is available. A wire of different thicknesses, length and material are there. A set of 10 gram masses and a set of 100 gram masses. What does it mean? Like set of 10 gram masses, like you will have 10, 20. Yeah, like you can have a 10 gram masses and you can increase like 10, then you add 2 of them, 20, then you add 3 of them, become 30. And a wooden rod is there approximately 1 centimeter diameter. You have to, this is a part, the main experiment, plan an experiment. You have to plan an experiment which enable us to test the extension of a spring made from different material. In your plan, instruction to make a spring from the wire. So how, for example, we have a wire. We want to make a spring. So they already mentioned we have a wooden rod is there. As you can see, a wooden rod approximately the extension means increase in length. How much the length increases, that is refers to extension. So how we can make a spring by using this? So what we'll do, the spring can be made by widening the wire around the rod. Like if this is a wire and this one is a wooden rod and I want to make a spring. So what I will simply do, I will wind this wire around the wooden rod. When I wind this wire around the wooden rod and I remove the wooden rod, then what it will turn? It will turn into a spring. So the first part, that how we can make a, and whenever you're writing the experiment, you try to answer the question like each point separately. So by winding the wire around the wooden rod, that's how we can make the spring. That's the first thing. Then what we will measure, because we want to measure, like we are investigating how the extension is affected by type of the wire or type of the spring. So what we'll do, we'll measure the length of unloaded spring. Then we will measure the length of the loaded spring, and to calculate the extension means how much the length has increased. So we'll measure the length of unloaded spring, and then we'll measure the length of a loaded spring, and we calculate the extension by taking a difference. So the thing which will measure the length of unloaded spring, or original length you can also say, and length of loaded spring, and we will calculate the extension by taking difference in the length. And the other thing, the load which is added, the length of unloaded spring, and then the length of the loaded spring. And just take a difference to calculate the extension. Is it clear?
Yes, sir, clear.
Then instruction for carrying out the experiment, like how we will do this experiment, how this experiment can be done. So what we will do, the procedure for this experiment, we will hang the spring, and we will measure the length of a spring. Then we will add load, measure the new length. Then we will add more load, because like we'll add a load and we'll calculate the new length. Then repeat the experiment, different types of wire, or the different types of a spring, or the different material of a spring. The variable which will keep same for a fair comparison. Like example, if one spring is made up of iron, another one is example made up of copper, another one is a brass. What are the parameters we should keep?
Same length, same diameter.
Same same length should be there, same diameter, because we are using a same wooden rod. So same length, same diameter, same set of load.
Can it be, Mr.
Yes.
Like deformation, like it can deform, so we must make it the same.
So same set of load is what is I mentioned. Same diameter, same number of the coils. So the number of the coils which we use, that should also be same. Any precaution you should take, or difficulty? So what precaution we should take whenever we are doing this experiment? Like as I
Read
mentioned,
perpendicular to
yeah,
the scale
look
to avoid
perpendicular.
parallax error.
Yeah, look perpendicular, or allow or measure the length when the spring stop vibrating. Or when we add a load here, maybe the spring might, or the clamp or the stand might topple. That is also a difficulty. So any precaution you will take? So we will look perpendicular, avoid parallax error, and we will wait for spring to stop vibrating. And what might be the difficulty? Maybe the clamp and the stand might topple. That is one difficulty. Because they ask any precaution or a difficulty. And the last one, how you'll present your result. So what we can do to present our result, usually we, whenever we want to present our result, we'll represent by a table, and table must be with a column heading. So, or we can also plot a graph. Like example, we have material A. This one will be a load, an extension for material A. Then you can have the on the same table, you can have both of them, or you can draw a separate table. But table must be with the column headings. So here we have load and the unit is Newton, load, the unit is Newton. Then we have a length of a spring, and then we have extension. Millimeter or centimeter, it's up to you. This will be load, length in millimeter, centimeter, and extension. Usually we use millimeter, but centimeter is also correct. Table, yes, table. You can use pen here. It's not an issue. Then this is for material A, the spring made from material A, and the spring made from material B. Or you can also plot a graph between how you present your results. So you can also plot a graph between force and extension, or length and extension, or extension and load, and compare the gradient or slope. Because the one which is having a higher slope will have a smaller value of a k, because its slope is inversely proportional to k when load and extension are there. So how you present your result, and when one important point is like repeat the experiment is the most important one. Whenever experiment, like repeat the experiment 5 set of loads. So this was the planning experiment, how we can investigate like how the material can affect the extension of a spring, or type of a spring is affected by the, or extension is affected by the type of a spring. Is it clear, this one?
Yes, sir, clear.